Hi again, and welcome to Lesson 8 of Android App Development Training Course. Today, you will learn how to use the lazy initialization in Kotlin. We will explore and handle the different lifecycle events and trace these various events as it fires using the Logcat window. You will learn how to manage and restore your app's UI state after an orientation change, and at the end of this lesson, you should be able to create your own slot machine application and apply the aforementioned concepts. To demonstrate this, I already created an empty project and modified the layout to look something like this. It consists of one text view, TV display, three image views that are vertically aligned, and a button named Button Draw. I also created a landscape variation with the same text view at the top center. The three image views are now aligned horizontally, and the button draw is positioned at the bottom center. Note that these image views are currently using the default avatars, and these will not be visible during runtime. So, let's check our app's layout in the emulator. Our text view displays a message, "Show that apple," and here is the button draw. I'll change the orientation to landscape, and here you can see the same text view. The three image views still don't show anything, and the same button draw. I have also configured the view binding and set it to true, and use it here in the main activity on create function. So if you want to follow along, make sure that you have this initial setup first. With the view binding enabled, we usually do this. We access all the views through this binding variable. However, if you are going to reference this view several times in this entire class, you might want to create another class level variable that references this view. I'll declare a separate variable, val button draw, and initialize it to binding that button draw. Although this one looks good, but running this code will cause your app to crash. I'll relaunch the app for you to see that it crashes. The reason why our app crashes is that we already used the binding variable even before we instantiate the binding class and use it in the onCreate function. I'll copy this code and comment it out here. Now notice that if I move the declaration and initialization of this button draw using our binding variable inside the onCreate function just right after this setContentView call, our app works fine. The only problem here is that button draw variable is local to this function and cannot be accessed outside this onCreate function. So I'll remove it here and then enable this code again. And so instead of using this equal operator to initialize this variable right away, I'll replace it with by lazy and place this binding that button draw inside this block. When using lazy initialization, your variable will not be initialized unless you use that variable in your code. So, the moment we use this button draw variable here, that's the only time it gets initialized. Let's try this in our emulator and see if it works. And our app didn't break. I'll create another lazy initialization for our text display. And then finally, I also want an array of our three image views, and I can do a lazy initialization like this. List of, and then a reference to image view 1, image view 2, image view 3. You can also specify the type if you want. I have also added 4 image resources here, same with the ones that we use in Lesson 6, apple, empty, grapes, and orange. I'll close these windows, and in the onCreate function, I want to dynamically initialize the content of the 3 image views. I'll create a function called initImageViews and use the intention action to generate this function. Having an array to reference all the 3 image views in our layout, I can use a for loop to initialize all our image views like this. For each I, that's set image resource, and set everything to empty. Now, let's see it in the emulator. And the 3 image views were initialized to display the empty image. So now, I'll add some functionality to this button draw. That when I click, I'll call the drawSlotMachine function. Using the intention action, I'll generate this function as well. What I want is that every time this button draw is clicked, it randomly displays fruit image to the 3 image views. Since I've demonstrated this similar functionality in Lesson 6, I'll use a different approach here instead. I'll declare another variable called images. This is of type int array. This variable will hold 3 resource IDs of the random image that will be generated. So, to generate a random image, I'll create another function called randomizeImage. This returns an integer resource ID of the random image. And now, instead of shuffling the list of resource ID like what we did in Lesson 6, I'll use the random.nextInt and pass in a parameter of 3. It means that R will hold an integer value of either 0, 1, or 2 every time this code is executed. Using the when statement, I'll use this random number of 0, 1, or 2 to determine which resource ID I'll be returning to the calling program. I'll place the else part since it is required for when statement when used like this. And then I'll create another function to set the content of these images int array. I'll call it setRandomImages. Inside this, I'll assign the images variable using the int array of function and set 3 random image resource IDs that will come from the function randomImage. So, when the drawSlotMachine is called, I'll call the setRandomImage, and then I'll display these 3 random images using the for loop. Although I can use the array indices to accomplish this, but to show you a different way, I'll use the until keyword to loop from 0 up to the array size less than 1. It doesn't matter which of these two, both have 3 elements. And inside, I'll access the individual image views and set the image resource using the randomized image resource IDs from the images int array. Now, let's run and test our app, and when I click this button draw, it successfully displays 3 random fruit images. And now I want you to pay attention what happens when I change the orientation to landscape. The random images were removed and resets to 3 empty images. I can click draw, but when I change the orientation again, it resets everything. Let's try a different scenario. I'll click draw and then I'll press the home button. Now, I'll press the resend button to reopen the app, and you'll notice that the previous UI state is preserved. But then, what happens if I press the back button, and then press the resend button again to reopen the app? Notice that the UI state is also reset. I'll collapse this function and explain to you the activity lifecycle events in Android. In Android, although activity doesn't always have a visual component, like for most IoT devices, but on a more conventional Android phones and tablets, an activity defines one or more of the app's screen, and each activity goes through a life cycle. This is a series of states as the activity appears and disappears from the screen. As the activity is created and appears on the app screen, the onCreate function is first called automatically from the app framework. This is just one of the many callback functions that you can override in your activities. After the onCreate function, the onStart function is called, and then the onResume. These functions execute in quick succession, and then the resume state is the resting state where the user can interact with the app activity. And then, when the activity is closed, it goes into pause state and then into the stop state, and finally, the onDestroy function is called. Another path is possible, like when you press the home button, you can go from the stop state through the onRestart and then to the onStart function. Also, from the pause state, you can go through the onResume. To demonstrate this, I'll use the log class from the Android.util package, and use this I for info. This requires me to pass two arguments, a string tag and a string message. This will be used to filter messages in the Logcat window. I'll put a message on create fires. Note that this tag doesn't exist yet, and I want to create a string constant for this one. Although, I can create this constant in this current class, but to make it accessible to the entire application, I'll place it in a separate file. Inside this base package, I'll right-click and then New, and then Kotlin file. I'll choose File, not a class, and then give it a name, Constants. I'll create a constant val, show image tag, and assign it with a string show image tag. I'll copy this string, and then I'll open the Logcat window and paste this string to filter the message. And now, when I run the app, the Logcat message displays on create fires. I'll click the back button and then relaunch it again. And now you see the on create function fires again. Going back to the code, I'll copy this log message, and aside from this onCreate function that fires once when the application first launch, we can override the other callback functions like this. I'll type onStart and then hit tab. This autocompletes the onStart override function. And just after this super.onStart, I'll paste this log trace message and replace this onCreate with onStart fires. I'll do the same for the rest of the callback functions and the activity lifecycle. I'll clear first the content of this Logcat window and maximize this window. And now, watch the log as I run this app. The onCreate, onStart, and onResume fires. And in the resume state, user can interact with the activity. Now, watch the log as I press the back button. It executes the onPause, followed by onStop, and then onDestroy. I'll relaunch the app, and again, you'll see the onCreate, onStart, and onResume fires in quick succession. I'll interact with the screen to change the UI state. Let me clear this Logcat first. And now, when I change the device orientation, you see in the Logcat that it destroys the activity and then it recreates again. This is the reason why the UI state is reset, thus it is not preserved. I'll change the UI state again and change the orientation back to portrait. And same cycle happened. It destroys the activity and then recreates it again. I'll show you how to restore the UI state in a while, but first, notice that a different path can be observed when you press the home button. Only the onPause and onStop get executed and not the onDestroy. And if I relaunch the app again, it goes to the started and then resume state. I'll clear this window again. And now, I'll change the UI being displayed and then press the home button. The activity is now in stop state and it is hidden but not destroyed. And when I relaunch the app, it is restarted and then resumed but not recreated. Thus, it maintains the UI state. I'll collapse these functions, and before I show you how to restore the UI state as the orientation changes, let me complete the functionality of this app first. For our show.apple slot machine, I want to count how many apples appear every draw and display a corresponding message for each apple count. I'll create a function named getAppleCount, and this returns an integer. I'll create a variable counterApple and set it to 0. Then I'll check each image resource in the images int array. If the random image stored in that location is equal to apple, Then I'll increment the counter. And then I'll return it. I'll create another function here that will display the corresponding message depending on the apple count. So, when the apple count is 1, although I can set the text display the text directly from here, but I will not do it first. Instead, I'll create another variable, message of type string. Then, set this message variable with nice one, and when the apple count is 2, the message is set to good for 2, and when the apple count is 3, the message is lucky 3, and in the else part, the message is set to show that apple. After this, I'll set the text display the text equal to this message variable. So now, when the draw button is clicked, it sets the random images, displays the random image to the image views, and then display a message depending on how many apples were drawn. I'll refactor this code and place it in a function called displayRandomImage. Initially, the display message is show that apple, and when I click draw, it says good for 2. And when no apple is drawn, it says show that apple. However, if only one apple, it says nice one. But now when I change the orientation, the UI state is reset. However, when I click the home button and relaunch it, the activity maintains its previous UI state. But again, if I switch it back to portrait, the UI is reset. So, in order to restore the UI state, as you change your device orientation, I'm going to create additional constant. This will be used to restore the message. I'll just type anything here. It doesn't matter what value you placed here. And then another constant, images. To actually fix this, I'm going to use this savedIntanceState bundle. This is a bundle that is passed into the onCreate function as the activity is restored. You can add values to this bundle as the activity is destroyed and then restore those values as it comes back. A bundle is a set of key-value pair, so to track these values correctly, you need a set of keys which are usually declared as constants. And just after this onCreate function, I'll type onSaveIntanceState. I'll use the second implementation, and just before the call to super.onSaveIntanceState, you can set this outState bundle to save any data that you want using these put functions. Since I want to save a string message, I'll select this put string. This expects 2 parameters of key-value pair. In the key, I'll use the constant message, and in the value, I'll use my class-level variable message. Recall that this message variable contains a value of either nice one, good for 2, and so on. I also want to save the content of images int array variable, so I'll call the outState.putIntArray, and then use the images constant as the key and a value of images variable. This images int array is the one that holds the random image resource IDs. Now, in the onCreate function, I'll restore this string and int array that were saved in the bundle. I'll comment this one because we will not be needing this anymore. So I'll retrieve the savedIntanceState and store it in the string message. Now, since this bundle is a nullable type, so I'll use this question mark and call the getString function and pass in the constant message key. You can see an error because this variable is nullable. It may or may not return a value depending on whether there is a saved state, like when we change the device orientation, or null when the app is first launched. In Java, you can use the if-else statement to check if a variable is null, and if it is not null, then you can safely access the variable. But when working with nullable variable in Kotlin, you can use a simplified version of that with the lvis operator. It is called lvis operator because it looks like Elvis with its head turned on the side. It only means that if it returns null, then I'll assign a string, show that apple. Similarly, to restore the images, I'll access the savedIntanceState and call the getIntArray function. I'll pass in the constant images as the key, and if it returns null, I'll return an array of 3 empty images. And finally, to display this message and the images back to the UI, I'll call this displayRandomImage and the displayMessage functions, and that's it. Let's run and test our app. I'll click the button draw several times to check if it still works same as before. And now when I change the orientation, we were able to successfully restore the UI state. I'll test the button draw again. And finally, when I change it back to portrait, the images and the message are restored perfectly. As a challenge, try to modify this slot machine app so that it consists of additional text view that displays your total coins. When you launch your app, your initial coins is set to 10. Also, instead of just one draw button, you now have 2 buttons that represent your bet as 5 coins and 10 coins respectively. Say I bet 5 coins. And since no apples were displayed, I lose 5 coins. And my total coins is now only 5. If I try to bet 10 coins, which is more than what I have, a snack bar message will appear saying, "Not enough coins to bet." And then, if I change my orientation, the current total coin remains the same. I'll bet 5 coins again, and sadly I lose. I can no longer play this unless I close and reopen the app. So, I'll bet 10 coins. And now I have a total of 20 since 1 apple appears. If 2 apples appear, then the bet is doubled. If 3 apples appear, then the bet is tripled. And if no apple appears, then you lose that coin. Again, thanks for watching. If you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo, and hope to see you in the next video lecture.